Yeah, that's a very good title. 1.5, what now? There is a simple answer. What next is going to be very, very much higher than 1.5. So I'd like to take a look at this from the point of view of the near-term future. What does 1.5 mean today? What does that mean for all today's children in the world and most of life on Earth in the future?
Hello, and welcome to another edition of the Climate Emergency Forum. I'm Herb Simmons. I'm the author of A Climate Vocabulary of the Future and co-founder of the Healthy Planet Action Coalition. And today's program is called Bye Bye 1.5. Now what? And of course, for those of you who are following, most know when we talk about 1.5, it's more than a number. It's more than just a symbol. It's actually a kind of summary of the world's climate and its relationship today to what it's been in prehistoric times. And we have with us our usual two experts who will talk about all the ramifications of 1.5, what it means, how high we are, where we're going, and how you should be concerned about where we are on 1.5. I want to invite you, if you like this program, to like it, to subscribe to our channel, to go to our website, climateemergencyforum.org, and press the donate button because our ability to do these programs, and we've done over 200, depends upon your ability to support us. And so we really, really appreciate that. And with that, I want to start by introducing Peter Carter, Dr. Peter Carter from British Columbia, who is a retired medical doctor, the founder of the Climate Emergency Institute, an expert reviewer for the IPCC. And Peter, why don't you start us off today on what 1.5 is all about and why we should be concerned?
Yeah, that's a very good title. 1.5, what now? There is a simple answer. What next is going to be very, very much higher than 1.5. So I'd like to take a look at this from the point of view of the near-term future. What does 1.5 mean today? What does that mean for all today's children in the world and most of life on Earth in the future? Well, the first thing that makes 1.5 much higher is that there is a lag commitment. And that's explained in the sixth assessment of the IPCC, who explain with the strongest mitigation. Of course, we're doing the opposite to mitigation still now. But with the strongest mitigation, you won't even see a temperature change. It'll smooth out, but you won't really see a temperature change for 20 to 30 years. So we're at 1.5 C plus 20 to 30 years of the rapid rate of warming that we're at. And then it's higher than 1.5 because we know we have feedbacks and we know the feedbacks will increase. And it'll be higher than 1.5 because we know that the carbon sinks are weakening. So that's all definite science data today, way above 1.5. So, people who are debating whether it's 1.5 or not, I mean, they've lost it as far as I'm concerned. So, what do we have actually on the planet today at 1.5? Well, we have amplifying feedback. We have already wetlands emitting more methane. We have the Arctic has switched from a carbon sink to the carbon source. A third of the Amazon, at least, has switched from a carbon sink to a carbon source. And worst of all, a recent paper explained that the ocean, not only is the ocean carbon sink weakening, but the ocean absorption of our heat from our greenhouse gases is weakening. So there we have a number of present data thoroughly assessed. We are committed, unavoidably committed to far, far above 1.5. I just want to repeat myself now. What do we have to do, or what did we have to do to avoid 1.5? Well, although nobody is even talking about it yet, the sixth assessment of the IPCC said that global greenhouse gas emissions peak between 2020 and 2025, 2025 at the latest, and that's for 1.5 degrees C and 2 degrees C. I don't find anybody anywhere saying that, apart from James Hansen, of course, saying that we have to have our emissions into decline now in order to avoid 2 degrees C. So I will finish off with a very important press release and short article by the UK Met Office. That was 17th of January this year. And the headline of that is the UK Met Office calls for immediate 20% cut to global greenhouse gas emissions. It was very clever and very helpful of them because what they did was they took the CO2 trajectory and they found that today that CO2 trajectory is off 1.5. Okay, that's another way of putting it, where our emissions and our atmospheric CO2 concentrations are increasing faster than ever, and that is way faster for us to be able to control the future to 1.5. And they say this can only be done by immediate cut in global emissions of 20%, and then they say repeated year after year after year, 20%. So there we are. We are in a terrible situation, rapidly getting worse because our governments are doing nothing. They're doing worse than nothing. We really do need, and I would put a plea in for this, we really do need a lot more of the public, getting seriously involved in this, where we've never been in more serious position. So, of course, this is what we're trying to do with our climate emergency forums.
Thank you, Peter, for your sobering but very realistic and accurate description of where we are and the fact that, and when you speak of feedbacks, what you're really saying, I think it's fair to say, and correct me when you speak later if I'm wrong, that as these feedbacks accelerate, basically, that means that the feedbacks are taking the climate out of humanity's hands, essentially. That nature is taking over, the Earth system is taking over from us, because even if we stop our emissions or slow them down dramatically, these feedbacks are the equivalent of a snowball rolling down a hill or so, and it will continue rolling. And it's still near or at the top of the hill. It's not in the middle of the hill, but it's starting to roll down very slowly, but getting a little bit faster. And the question is, do we as humanity, the 8 billion of us on this planet, are we going to just sit there and say, oh, look, there's that snowball starting to roll down the hill. And when it gets near the bottom, that's it for us and everybody else? Or are we going to actually say, let's mobilize and do something? So with that, and please correct me if my metaphor or description is incorrect, I'm just, as always, delighted to introduce Paul Beckwith, a climate systems scientist from Ottawa, who continues to produce. And I wish I could keep up with all your videos on YouTube, Paul. Just seen one or two that just in the past couple of days come out. Well over 1,000 videos covering every aspect of the climate crisis. And the floor is yours, Paul.
Thank you, Herb, sorry. I've got Peter, Paul, and Mary on the brain. Yeah, so 1.5. So we've surpassed that in the last few years, 2023, 2024. The question is, will we remain over there and have to be talking about 1.5 in the rearview mirror or in terms of overshoot, trying to get back down? But basically, this year probably be not quite as warm as in 2023, 2024, although James Hansen, who was mentioned, wouldn't be surprised if it is. His work recently has showed that from 1970 to 2010, we were increasing 0.18 degrees Celsius per decade, global average temperature wise. And from 2010 onwards, that number doubled to 0.36 degrees Celsius per decade. His baseline, it's very important to talk about the baseline because 1.5 is a change from what we have now to what we had a number of years ago. So the baseline that's commonly used is either 1860 to 1900 or 1880 to 1920, as Hansen uses. And the problem is with the baseline is that from the best I can see in 2015 in Paris, when the concept of staying below 1.5 and obviously aspirationally staying below 1.5 and the big target then was 2 Celsius, they didn't really clearly define pre-industrialization, but the literature before then said 1750 was sort of pre-industrial, right? They just used the term pre-industrial. The problem is if you look at the temperature difference between 1750 and 1880 to 1920, you get anywhere from 0.15 degrees Celsius is the most likely, maybe zero point 0.2. Some sources say zero point 0.3. So, when we talk about staying below 1.5, if you talk about the original language from the Paris Agreement, we've already well over it. So, and the baseline is important. Like, why don't we make the baseline 1950 and then we can say we're only at 1 Celsius, right? Clearly, that number 1.5 is only meaningful if you know what the baseline is and if the baseline doesn't change. Same with 2 Celsius or any other temperature. What's interesting, Peter's mentioned the increase and others, you have too, Herb, the great increase in emissions, in anthropogenic human emissions, the emission sources from wetlands and other parts of the earth, so-called natural emissions, if you like. The problem is just based on a very interesting but important analysis of the Keeling curve, which is a measurement of how CO2 varies on a year-to-year basis. The record on Mauna Loa, Hawaii goes back to 1958. Hopefully, we still have access and don't lose that record with the U.S. Present U.S. Government. But if you look at the curves of fluctuation year to year, the actual the CO2 level, it goes up and down. The reason it goes down is when we hit the boreal summer and all of the plant vegetation on land comes to life, absorbing huge amounts of CO2. And then it starts going up again in the boreal fall. That drop is about 7 parts per million from the vegetation. It's called the natural sinks or natural. It's from the biosphere. The oceans absorb at a steady rate. Southern hemisphere, not a lot of land masses, so it's mostly ocean stuff. And the land masses, Australia, South America, have vegetation, but it's nowhere near like the vegetation in the northern hemisphere. Anyway, the worrying thing is that those natural sinks from the biosphere, they peaked in 2008. And since then, they've been dropping. So, in other words, even if we stabilized our emissions, if we're still going to be losing the natural sinks, then CO2 levels and other greenhouse gas levels will go up in the atmosphere, and that will further accelerate climate change. So, this is a concern. And the last point is that nobody lives in the average. And we talk about 1.5, that's a global average. Of course, the poles are warming much faster. The Arctic is warming at least 4 times faster. Some studies show 5 to 7 times faster, depending on the latitude. Antarctic's warming at double the rate. The AMOC slowing down is a concern, not just for northern hemisphere cooling, but the tropics and southern hemisphere warms more and more. And we're seeing record temperatures down in Australia and record numbers of storms. Big cyclone is heading right now for Brisbane as we're filming this video. So the point is that the destabilization of the climate system and the temperature gradients with latitudes and therefore the ocean circulation and atmospheric circulation, all of that is changing abruptly or very quickly from accelerating climate change.
Thanks, Paul. I think it's important when we focus on the what next part of the description of today's program is to recognize that, as Peter says, rapid and sharp, use your adjective, your choice of adjective, abrupt, sharp emission reductions are essential, but they're only one of the 3 legs of what some of us feel need to be done. Paul, you describe it as the 3-legged stool. I call it the climate triad. Again, emission reductions are essential. They're extraordinarily difficult to achieve. We can as many others do, exhort governments of the world every week to do more. But the last time I checked, they don't listen to us very much. But what is also necessary is to begin to figure out ways to significantly, at a large scale, pull down the excess CO2 that's in the atmosphere that basically is the primary driver of climate change. If you dropped all emissions, things would not start cooling or would not stabilize right away. But if you pulled all the CO2 out of the atmosphere, you wouldn't have that greenhouse effect. Of course, that's extremely difficult to do, extremely technologically challenging, uses lots of land, energy, and so forth. And the third, though, is to directly cool the climate through putting some kind of sunshade or sunscreen over the planet. It's the most controversial, but it's the one at very little cost relative to the others and very quickly can bring temperatures down. And so I think when we talk about what next in terms of policy, I would at least urge us all to look at all three legs of this triangle and not just the emission reductions, recognizing that emissions are absolutely essential. With that, I want to turn it back to Peter.
Thanks, Herb. And thanks, Paul, for mentioning a very important point that there are regions of the world which are already heating up even faster than we're heating up here in Canada and the United States, Pakistan and India, the East China Peninsula, Central Africa. They are very, very hot today already. And as I say, we're not actually at 1.5 degrees C from the point of view of mitigation and from the point of view of trying at least to prevent total climate catastrophe. We're way above 1.5. So I find this 1.5 focus and discussion not a very helpful thing, but not a very helpful thing in a different sense than most people are talking about. And that's because it's going to be far, far higher. What we have to do, and this is no question, this is a question that it is a question of our very survival and the survival of most life on Earth. So, what do we have to do? I'm going to give a suggestion, and I'm going to immediately say that I'm not looking at feasibility. I'm looking at what we would do to save ourselves, basically. Herb mentions the people call them geoengineering or intervention methods, probably a better term. Yeah, we're clearly going to have to do that. There's no question, but we can't, okay? Because we actually don't have the technology yet. We've always known that we have to remove some CO2 to stabilize the climate. We've always known that. As every IPCC assessment comes out, they assume even more removal of CO2. But we have no capacity for doing it. The popular idea of burning forests and capturing the CO2 is a horribly ridiculous idea. So that's why I say we definitely need a Manhattan Project now in order to intervene rapidly and safely with the way our climate is going. And if you combine the data with the fact that the governments are doing worse than nothing, they're still subsidizing fossil fuels, that puts us in a runaway. That puts us in a global heating, climate disruption, runaway situation. So when the IPC and the Met Office says that we have to reduce emissions globally immediately, it doesn't matter how impossible or unfeasible that seems to be. We should, the scientists should all be shouting this from the rooftops all the time. A couple of them are, but we need way, way, way more than that. So, Manhattan Project to safely and securely extract massive amounts of CO2. And also, we should be experimenting with some cooling. And the way to do that, as many of us have been talking about for years, would be to start cooling the Arctic because the permafrost is thawing and it's emitting all three greenhouse gases, methane, CO2, and nitrous oxide. So that's what we got to do.
Thank you, Peter. You said it very clearly and very, very eloquently. For those of you in the UK who may be traveling there, there is a conference at Cambridge University at the end of June on Arctic repair techniques. And I would encourage you, maybe we can put a link to that here, to consider registering for it or following it. I'm sure some of the programs will be online or available after the conference is over. And I want to turn it back to Paul now.
Yes, well, thank you, Herb, and thank you, Peter, also for your comment. So, yeah, the idea of we like to set targets and we like to set simple targets. I mean, trying to get back or stay at 1.5 is the whole reason why that was initially became an objective of the 2015 Paris Agreement. And I was fortunate to actually attend that conference. That was the second COP that I attended. I was in the Lima conference in Peru the year earlier. It seems like, that's over a decade, that's a decade ago now. And, it looks like we're roaring past 1.5. So we go then to the next target of 2, but we're also hearing a lot of talk about overshoot. Well, overshoot meaning, let's go back to 1.5. If we bring in the word overshoot, we can not discard talk on 1.5, but we can keep it alive, right? We can continue to talk about 1.5 and say, how do we get back down? The problem is that the action at the global level just isn't there to have any hope of getting back down. We tend to focus on human emissions, but if we did come up with some sort of magical, put in quotes, magical right now because it doesn't exist, but if you're a technology person and you have absolute faith in technology, then you can say, well, we're going to come up with some technique because we don't have a choice to pull CO2, and we should talk about methane as well out of the atmosphere so that we can reduce temperatures. How would we do such a thing? And then when we realize that that's very, very difficult to do, I mean, I like natural sink methods the most, right? For example, we've lost 90% of the large marine creatures in the oceans. Think of how much carbon is embodied in whales, for example. When whales excrete, they're sending carbon to the seafloor where it can be sequestered for long periods of time, right? So you have to look at the whole chain of life on the planet. And since we've diminished it and we've kind of focused it on specific species, think of the number of chickens on the planet or the number of cattle, for example, right? I mean, we've lost the biodiversity and these complex ecosystems that can be enormous sinks of carbon. But all of these things take time to restore. I mean, we could restore the ocean life if we chose to do so as a species, but that's going to take a lot of time. And this is why those other methods, these solar radiation monitoring management or ideas come in, because those things can act very quickly and they can buy us time to do these other things, to kind of try to stabilize the planet. But we're up against all of these massive tipping points in the climate system, and we could be, we have probably already surpassed some, and it's very conceivable that we'll pass the tipping points in the way the ocean circulates heat and nutrients. I'm talking about the Atlantic Meridional Overturning Circulation, because that failing would really rewire the way things move on the planet, and it would lead to utter climate chaos for humanity. Our ability to grow food, to get fresh water, all of these things that we need to survive as a species will become much harder to do when we cross these major tipping points. So, you look around at sort of, we've been trying to say, I mean, look at the name of our group, Climate Emergency Forum. We've been trying to say it's an emergency, but, when that word floats around, emergency, the way the human brain works is we kind of get used to that term. That term loses its effect. It no longer, calling climate an emergency, we have to act sharply. When we continue to call this and nothing happens, eventually people say, well, yeah, it's an emergency, but, big deal, right? I mean, the word loses the power that it would have initially. So this is a problem, and this is the way the human brain works to process things and understand reality, and survive. I mean, so some of these evolutionary traits of the way we think and the way we act are actually working against us. And we're going to be, the climate system is going to do what it's going to do. If we start getting emissions from the Earth-ocean systems that far exceed human emissions, and the game is basically taken out of human agency, or out of our hands, and we just have to try to deal with the chaos that we're going to see as a result, mostly in terms of growing food and getting fresh water to sustain people on this planet.
Thank you so much, Paul, for those. Again, we've heard a lot of sobering words today. Sobering words, accurate words, scientifically appropriate words to use, even if we don't always hear scientists themselves being so direct and so blunt. But that's part of what I think what we do is we speak the truth as we know it, and we don't filter it through jargon or indirection or whatever, because I think that's what's necessary. I mentioned earlier about the conference in Cambridge on polar Arctic ice repair. Right after that, coincidentally or otherwise, also in the UK at Exeter University, the first couple of days in July, is the second Global Tipping Points Conference. And Exeter is the center of intellectual excellence on tipping points on the planet. So again, I would encourage those of you in the UK, if you can go to that conference to learn more about tipping points, which of course are the primary, if not the primary reason why we need to be so alarmed. Is once things begin to tip, they're very difficult, if not impossible, to untip them. And with that, I want to thank Peter and Paul, as always, for the remarkable job you do in synthesizing so much information that's out there. Please like this video. Please subscribe to our channel. Please leave your comments, your ideas for the issues and topics we should address in the future. And please go to our website, climateemergencyforum.org, and read all the articles, see our videos, and don't forget to press that donate button. So with that, I want to thank you very much for watching this today, and we'll see you next week. Take care.